Welcome to Cloud on Air, live webinars from Google Cloud. You're watching DevLab, where we dive deep into cloud solutions and learning for cloud developers. My name is Lak Lakshmanan, and today we'll be talking about the new update to our data engineering course. You can ask questions at any time by submitting them in the box below the screen. We have Googlers on standby to answer them. So let's get started. So as I said, I'm Lak Lakshmanan. I lead data analytics and AI solutions on Google Cloud. And today, we'll talk about the updated data engineering on GCP course and show you some demos that you will get to see as you dive into the courses. If you stick around until the end, we'll give you a special course offer and wrap up by answering some of your questions. Let's start with a course overview. So this is a major 2.0 revision for data engineering. And in here, our team focused on 5 major points of feedback that we got from earlier learners of this course. First, that we now have dedicated machine learning instructor-led content in the field, and that's called Machine Learning on GCP. And because of that, we wanted to move all the granular TensorFlow model building out of this data engineering course into the specialized course on machine learning on GCP. So the course participants in the data engineering course will still build models, but they'll do so using BigQuery ML and pre-trained ML APIs. Another great point of feedback that we got was on adding content and labs on Cloud Composer. Absolutely, this is a great tool in the engineer's toolkit that wasn't there when we built Data Engineering 1.0. So now you have coverage on Cloud Composer and how to use it to orchestrate across services on GCP. We've added half a module dedicated to Cloud Composer and another half on a new product called Data Fusion. More on these soon. On the BigQuery side, you asked us to go deeper into what makes BigQuery so unique and how data engineers can prepare to build modern data warehouses. So we've added lots of new content and labs on things like partitioning, clustering, and nested and repeated fields, talking about array and struct data types. Now, whenever we're teaching these classes, learners really love it when we get off slides and start showing these things in Google Cloud. So in Data Engineering 2.0, there are a lot more demos, all of which are public, so that you can go back and look at them and you can see the code that was used to build those demos. Finally, another new thing that came out after Data Engineering 1.0 was released was BigQuery ML. And BigQuery ML has a continuous focus, and we've added 2 more labs in data engineering that's focused on building models with BigQuery ML. So at this time of the webinar, parts of BigQuery ML are still in alpha, but if you're doing the course, it's been whitelisted and you should be able to try many of the features out. So as you can see here, 2.0 is a major overhaul. There are lots of new labs for learners to explore, including Data Fusion, Cloud Composer, more advanced BigQuery labs, machine learning labs, and even some big table high throughput streaming in a lab. And one of the major efforts that we've been doing is that when we're developing courses, that we're taking all of these demos that our curriculum team and our lead developers are coming up with and storing them in a public place for everyone to benefit. So if you go to the GitHub repository, you will see demos on clustering, on recommendations, and more of these things as time goes on. So the specialization consists of 4 courses, and we'll walk through each of them in more detail. First up is a course on data lakes and data warehouses on Google Cloud. At a high level, you'll focus on creating data lakes full of raw data in Google Cloud Storage and Cloud SQL. There's extensive coverage of cloud storage buckets and the associated metadata with them. And after that, we will go ahead and look at data lakes when we look at how to do processing of data in data warehouses. This module, the building a data warehouse, has been completely redesigned to include the latest features that are advanced in BigQuery, things like nested and repeated fields, clustering, partitioning, etc. And we also looked at how to do federation from BigQuery to Parquet files and federation from BigQuery into Cloud SQL, things that start to blur the boundary between data lakes and data warehouses. So in course 1, we start the day talking about the core roles and responsibilities of a data engineer. And a data engineer is someone who basically builds data pipelines, starting from how to get the data to a place where it can be useful, and then transforming the data to make it more usable, adding value to the data, managing it, and productionizing the data processes. And data engineering is about this entire life cycle of what a data engineer does in their day-to-day jobs. So in the first day, we focus quite a bit on Google Cloud Storage and on Cloud SQL as your data lakes, and then delve into a deep discussion of BigQuery as a data warehouse. Sometimes, of course, BigQuery functions as a data lake depending on your ETL or ELT, extract transform load or extract load transform pattern, and we get into that more modern view of data lakes and data warehouses in the course itself. Once we've talked about the challenges to data engineers, we start to introduce a lot of the big data products on Google Cloud, and the different products that address challenges, whether they involve storage or ingestion or analytics or machine learning, or providing up the insights that have been created through the data pipelines. I mentioned before that the data lake discussion has a deep dive on cloud storage. We get into versioning and lifecycle management, and we even include a demo where we use cloud functions to do the lifecycle management automatically. Now, one of the cool new features is that now you can query Apache Arc file or Parquet files from Google Cloud Storage via federated queries from BigQuery. And this is one of the reasons why you'll often hear that data lakes and data warehouses are merging. We show how and why this is happening and how easy it is to implement this more modern view of data lakes and data warehouses on Google Cloud. So day 1 wraps up with a discussion of BigQuery architecture. And we discuss cool features like time travel. There is a suite of new data products on GCP that we mentioned using the Google Cloud Data Catalog and Cloud DLP or Data Loss Prevention APIs. Let's forget it. Okay. And my favorite topic of nested and repeated fields to enable wide and deep schemas. And we do this by using array and struct data types. There is a new in-depth lab in this section where students get a lot of experience working with arrays and with structs. And then we start to cover partitioning and clustering to close out our coverage of data warehouses in the first course. So let's go ahead and do a very quick demo. So this one is on BigQuery clustering. And as I mentioned, all the demos are on GitHub. So let me go over to GitHub. And here's where the demo is. There's a clustering demo. It's in our training data analyst. This is where all the labs and demos are. And here's an example of the query that we start with. So let's go ahead and go into BigQuery. And so what this query does is that it takes a data set of Wikipedia views and looks for English Wikipedia for all of the pages that were in after January 1, 2018, and tries to do a regular expression match. So it's a pretty computationally intensive thing over a massive data set. Let's go ahead and run it. And what you will find is that because this table has been partitioned, it doesn't have to read the entire table. It only has to read the partitions that correspond to Wikipedia views after January 1, 2018. Okay? So once this is done, what we will do is we will look at the number of bytes that were processed by this query. And let's go ahead and then we'll change this from 2018 to 2019. So in 2018, you notice that it took about 24 seconds and it processed 2.2 terabytes. So we did a query that did 2.2 terabytes of data and it took about 25 seconds. Let's go ahead and change the 2018 to 2019. So this should be, because we're now recording this in 2020, this should be about half the data. And you can go ahead and run this query, and you should see that, this is only a 2018 table. So let me go ahead and change this to be July. And let's see if we get half the data. So, wow, Wikipedia does 2 terabytes in a year. So this is now running. And let's see if by doing the partitioning by date, we should have gotten, yes, as you can see, we're now processing only 1.1 terabytes, so about half the data. The other thing that we can do is that their partitioning essentially says that we're going to take it and we're going to split it by date, and we're going to read only those partitions that correspond to the dates. But even within the partitions, if we know the kinds of things that we tend to use in our where clauses and in our group bys, we can change it. We can basically change the way that the data is ordered within the partitions. So that has been done in version 3 of this data set. So let's go ahead and do this exact same query, but in this cluster data set, we're saying that we know that people are going to be searching first for Wikipedia in a specific language. So cluster all of the Wikipedia views by language and then by title, right? And basically because most of your queries are going to involve queries of things involving a specific language and a specific title. Just knowing those, that's the very common way that queries are done, and changing the way that data is stored in the table, that's what clustering does. You now see that you basically got the query running much faster and also much cheaper, because it's now processing even less data than before. Exact same query, exact same results, but we're now getting much less data processed. So we just looked at partitioning and we looked at clustering, both of which are new features in BigQuery that allow you to get faster queries and cheaper queries. So let's go back to our slides. So we've now looked at course number 1. Course number 2 is primarily on batch processing of data using Spark and Hadoop on GCP. This content is largely the same as a previous version of Data Engineering 1.0, except that we've updated all of the labs to Python 3.0. There's a huge addition here, though, and the huge addition is this final chapter, which is around managing data pipelines with Cloud Data Fusion and with Cloud Composer. But let's walk through what this entire course is about. So we start our batch pipeline discussion by highlighting the 4 major products that we're going to be covering: Cloud Data Proc, Cloud Data Flow, Cloud Data Fusion, and Cloud Composer. So Data Proc is basically gets a lot of its efficiency because it's able to do separation of compute and storage. And by doing a separation of compute and storage, it's able to basically get the ability to ephemeral clusters. So you are able to get flexibility of using both GCS instead of HDFS and being able to get off-cluster storage to provide ephemeral clusters. So your clusters themselves can be ephemeral or short-lived, so you can focus on a single job and turn down the cluster while your data persists elsewhere. No discussion of batch or streaming pipelines would be complete without a deep dive into Cloud Data Flow as a serverless offering on GCP and where it fits best. So this course goes into detail on the optimizations that Cloud Data Flow does behind the scenes, like mid-job load balancing to get all of the advantages of a fully managed serverless way to do data processing. So students get practice learning the fundamentals of data flow pipelines in Apache Beam with P collections, and you basically get to practice it in your labs. We also discuss how to create templates and where you can find Google's pre-created data flow templates for common tasks like moving data from PubSub into BigQuery. Module 5, which is on managing data pipelines, is all new. It has content on Cloud Data Fusion, which is what you're seeing on the screen. It's a visual UI to wrangle and explore data, and to build pipelines. The module goes into a lot of detail, of course, so take the course for more details. But Data Fusion currently offers only Cloud Dataproc as its runner, but the team is working on adding other runners like Dataflow shortly. The last half of the module focuses on Cloud Composer, which is a managed Airflow environment. And you use Cloud Composer to orchestrate complex workflows across multiple GCP products and even non-GCP products and services. So as a learner in the course, you will learn how to create Apache Airflow DAGs and how to use them to perform common data engineering tasks. Since day 2 was batch pipelines, course 3, as you might expect, is on streaming pipelines. The content here again is largely the same as the previous course, but now we have added notes on BigQuery and Bigtable streaming. BigQuery streaming is now even more powerful than before. You can get up to 1 million rows per second. And so again, take the course for more details. For the streaming course, we walk through the typical architecture, and this is the typical architecture on Google Cloud, where you're receiving events in real time from PubSub, creating a serverless data processing workflow in Dataflow, and streaming those into a sink, which is either BigQuery for data warehousing needs or Bigtable if you have high throughput needs or real-time needs like IoT, etc. And regardless of where you land the data, the rest of GCP is then open to you for doing things like machine learning and for being able to call unstructured machine learning services. So the first part of our reference diagram was Cloud PubSub, and we go into detail on Cloud PubSub, which is around topics and subscriptions and what the relationships are and how to set up both push and pull subscriptions. We also highlight the benefits of combining PubSub and Dataflow, where PubSub provides guarantees of guaranteed delivery, and Dataflow basically adds onto it deduplication, ordering, and windowing. And this idea that the separation of concerns allows Dataflow to scale massively. So we highlight the benefits of using these two services together. And then we dive deep into Dataflow. We talk about how to do streaming in Dataflow, how to handle lags in data, how to do different kinds of windowing options. And we basically talk about how to handle changes where if the data arrives later, and how to basically do processing after the fact with triggers, etc. in Dataflow. And then we close out day 3 on streaming with a discussion on high throughput streaming into BigQuery and into Bigtable. And there are new labs on these products as well. Since day 4 is all machine learning content, we also added a little bit of extra content on day 3 that doesn't quite fit the streaming scenario, but it's often used alongside streaming. So things like asset tracking with GIS. So we basically talk about how to do visualization with BigQuery GeoVis. Course number 4 is the last course in the Data Engineering Specialization. It's the last day of the Data Engineering course, and it focuses exclusively on smart analytics and machine learning and AI on Google Cloud from the perspective of a data engineer, not the perspective of a machine learning data scientist. So the TensorFlow material, as we said, is out of the course, but the model types that we are now able to support because of BigQuery ML are much more advanced than what we could do with TensorFlow. So the ironic part is that even though TensorFlow is out of the course, the machine learning capabilities that we cover in the data engineering course are much more advanced. We get into even building recommendation models in BigQuery. So the new content that we talk about here are Kubeflow pipelines, AI platform notebooks, the BigQuery model types, and AutoML. The day begins with a disambiguation of AI, ML, and deep learning to set the stage for the different model options on Google Cloud. And so this one talks about why you might use the different options that you have. how the types of products on Google Cloud that you would use to build a custom model, the kinds of things that you would use on Google Cloud if you want to do codeless model development, that is to get best of breed accuracy and to be able to do pre-trained models. Okay. You can execute BigQuery commands from AI platform notebooks, and so we talk about the Jupyter Lab magics that are available. And so you have a lab where you're basically connecting from a notebook to BigQuery and being able to do things like querying and being able to run machine learning models. And later in the day, we also cover Kubeflow pipelines, and there's a lab where you get to create a Kubeflow pipeline and be able to run a pipeline that involves pre-processing and training a model in parallel and picking the best score and deploying it for serving. So one of the cool things is that having trained a model, you can actually look at the different results. So we get into how to do an analysis of runs of the model, how to look at those analyses, how to monitor model performance, etc. And then we get into how to create machine learning models directly in BigQuery. And this is some of the most exciting content for data engineers in this course. We talk about how to build machine learning models using just SQL. So we now talk about how to build linear models, how to build classification models, but we've also added a new lab, which is around matrix factorization, which is a new thing that's currently in alpha, and I'll do a quick demo of this, but it allows you to use BigQuery ML SQL syntax to build extremely sophisticated recommendation models. So let's go ahead and do a quick demo of that. So here, as I said, mostly you can do this from AI platform notebooks, but because each of these steps takes a few minutes, what I'll do is I'll copy these things from my notebook and show some of the queries running in the BigQuery console itself. So here, the problem that we're trying to solve is on a movie lens dataset. So we're going to try to solve how to do collaborative filtering on movie lens. And this is basically based on chapter 9 of a brand new book on BigQuery written by me and my colleague Jordan Tigani. So here what we're basically doing is that we're taking a data set that's called Movie Lens that consists of movies and ratings by users. So let's go ahead and take a quick look at the data. So this is going to be from the rating data. So let's go down here and let's look at what the data looks like. So this is the Movie Lens ratings data. So there we go. So you basically have the user ID, the movie ID. Okay, so this is the user. This is the movie that they watched, and they rated it at 2.0 at this time. So this is essentially the data set. So as long as you can reduce your SQL queries to basically get a user ID, an item ID, and a rating, you are in business as far as matrix factorization is concerned. So once we have a table of this form, right, we can basically go ahead and see, well, how many users do we have? How many movies do we have? So let's go ahead and do that. So we will basically find the number of distinct users, number of distinct movies, and how many ratings there are. And this is just a quick bit of data exploration over the data set, so we know how big it is that we're basically building a matrix factorization model out of. So it turns out that there are 2 million ratings in this data set. There are 138,000 users and 27,000 movies. And that's basically the data set that we're going to use to build a matrix factorization model. So here, what we're now doing is that we're basically saying select the user ID, movie ID, and rating. So those are the 3 columns that we looked at from that ratings table. And this is all it takes to build a recommendation model. Saying, I want to create a model called recommender in the dataset movie lens, and it's going to be a matrix factorization model The user column, remember, you need a user column and an item column and a rating column. So you just say which one is which. So my user column is user ID, my item column is movie ID, and my rating column is rating. And once you do this, this takes a few minutes. So I will launch this off, and then we'll walk through the rest of the notebook as we go through it. So this is basically what we need to be able to do. Okay? So it's here. And because we are writing into a data set called movie lens, let's go ahead and add a new data set in this, create a data set called movie lens to write it out into. Okay. So create that data set. So that's going to be my output data set. And that's pretty much it. I can go ahead and run this and let this keep going. It'll take a few minutes to run. And meanwhile, we can walk through the rest of the notebook. So once this is done, okay, you can then go ahead and try out, right, what it looks like. And you can also have other options like adding in L2 regularization, changing the way ratings work, etc. So this notebook walks into some of the experimentation that you can do. One of the key things that you will want to do is to decide how computational, how expensive this model is going to be in terms of, or how granular the model is going to be in terms of representing users and representing movies. And the more number of factors you have, the more complex the model is. And the less number of factors you have, the more simple the model is. And that's one of the hyperparameters that you will have to experiment and tune. So we try different numbers, and we go ahead and we pick the one that comes up with the lowest error. And in this case, 16 is one of the things that we're trying here. And we basically realize that when we do 16, the evaluation loss is lower. Okay? So once we basically train our model, we are now ready to go ahead and do ML predict from it. Right? So this is how you're basically able to get the predicted rating when someone goes ahead and does, if I showed this movie to this user that they've never seen, what do you think they would rate it as? And the machine learning model will come back and tell us what the predicted rating is going to be. And then what you would typically do when you're serving is that for every user, so 903 is a user here, we'd basically go ahead and get all of the movies, order it by the predicted rating descending, and show them the top 5 predicted ratings. But because these are movies, and you don't want to actually have them see movies that they've seen before, you could also go ahead and filter out movies that they have already seen. And you see here that the movies that they have seen is an array, which is why we're basically doing an unnest. So at this point, we basically get our predictions. So just from SQL, we're able to basically do both training of the machine learning model, doing the matrix factorization, and being able to do prediction, to be able to predict what the rating would be so that we can then start recommending movies to customers. And that's one way to do it. The other kind of problem that you solve with matrix factorization is customer targeting. So you can recommend items to users, or you can find the best users for a particular item. So for example, let's say you're coming up with a new movie, and you'd say, well, let's figure out who's going to be the person who's likely to watch this movie, right? So, or you have a coupon and you have a promotion, and you want to figure out the 5 people that you want to send that promotion to. That's called targeting. And the way you do this is again with ML.predict, but where previously in ML.predict, we wanted to predict for a particular user, right? What the predicted rating would be for all movies. Here, what we want to do is we want to predict for a particular movie all of the users, and then basically go ahead and order by predicted rating. So it's again just SQL, just calling ML.predict makes machine learning a very, very, very approachable and easy for people who do SQL. And of course, you don't have to write the SQL. We now have tools like Looker, which will basically generate the SQL for you from a dashboard. So a lot of machine learning models these days are getting built out of dashboarding tools like Looker. Normally, of course, you don't try to go ahead and do predictions for a single movie or a single user. You want to basically do a batch prediction. Every night, you want to create the full set of recommendations for all your users and all your movies. And for that, we basically provide a very simple, easy ML.recommend option where you can basically pass in the model that you've trained and say, go ahead and generate the full matrix of predicted ratings. And that's pretty much it. You now have a matrix factorization model, and you've basically created a way to recommend items to users, and realize that all of this started from a data set where you simply needed just 3 columns: user ID, movie ID, and rating. So this makes it extremely powerful, extremely approachable, something that we're super excited about. So quickly now, I promised that at the end of the seminar, we'd basically do a quick course offer. So this is how you claim your offer. Go to this bit.ly link, sign up for a new account, and sign into your existing account, and then you can access a Coursera specialization of your course. Of course, we hope you pick the Data Engineering 2.0 specialization, but you can pick any specialization that you want. It's free for a month, so please see the Coursera site for additional terms. And remember that we're going to use a credit card, but you will not be charged for the first month, so you can cancel the subscription after the first month, and then you will not be charged. So this is now time for Q&A. Okay, so let's go ahead and look at some of the most of the frequently asked questions. So first question, what should I already know before I begin data engineering on Google Cloud Platform? This is a great question. What are your prerequisites? Well, the specialization has a prerequisite course. It's the Google Cloud Platform Big Data and Machine Learning Fundamentals course. So definitely, before you start taking these 4 courses, take the Big Data and Machine Learning Fundamentals course. Besides that course, or the equivalent experience of that course, you should have basic proficiency with command line tools, and some Python or Java coding experience would be very helpful. You should definitely know some SQL experience as well. Second question, what is the duration of the training? Well, it depends, right? So the 4 updated courses that I highlighted take approximately 22 hours total, about 8 to 9 hours each could be. And the Big Data and Machine Learning Fundamentals is about 9 hours to complete. So if you take all of these courses, to pace yourself, take it over several weeks, don't cram it all in. Make sure that you do all of the labs. Make sure that you practice with the demos. You learn a lot more by doing than by watching the courses. So I would really recommend that you don't think of this as the minimum amount of time that you can do to complete the training, but that the amount of time that you need to absorb the training. And that tends to be a little bit longer. So pace it out, do it over a few weeks. How does this specialization relate to the professional data engineering certification? So this specialization is part of a recommended learning path for specialization. But notice that I didn't say the specialization is the learning path for the specialization. I said it's part of a recommended learning path. And the reason I'm saying it's part of it is that simply taking this training is not enough preparation to pass the certification. So you do need to have some of what I talked about in terms of practicing with these things and getting some hands-on experience. So we provide a lot more information on the learning paths and the specialization on our certification site, We'll drop the link to the certification site. Please take a look at it. So this training course is part of the recommended path, but it is not sufficient. You should think about adding more practice to it. We have a set of quick labs that you can use to go ahead and do a practice. There's a whole bunch of other things in our recommended learning path. Fourth question, does Google Cloud offer training courses for other job roles? Yes, definitely, right? So if you go to our training site, we have a specific section on role-based learning paths. So we can even take a look at it by going into learning paths. Let's see if I can bring that up. Okay, there we go. Here, there is our training content, and you can see that from our training courses, right, you basically have a variety of different learning paths. And the one that we're talking about here is a data and ML, but there are other learning paths, and we really recommend that you use this site and you delve into the site and look at the different learning paths that are available for you, right? So this is the learning path for data analysts. This is the learning path for data engineering, and here's the learning path for data scientists. Okay, cool. Are there any other questions? Yep, all right. Let me just head back very quickly to an important announcement, which is on Cloud Next. Okay, right? So remember that Cloud Next is April 6 to 8 in San Francisco. We hope to see you there. Please join us at Cloud Next for hands-on demos and labs. Use this code to get $500 off your ticket. You can register now at g.co/cloudnext. Come join us there. And in closing, thank you for tuning in. Please visit Cloud OnAir for more content from Google Cloud experts. Thanks.